Welcome to part 3 of our SQL full tutorial. In this session, we will continue exploring database engineering and coding techniques. Let's dive deeper into SQL functionalities and enhance our understanding step by step. In SQL, data retrieval often involves using simple aggregates. The count function can count all rows or specific expressions, excluding NULLs. MAN and max functions find the smallest and largest values, respectively, applicable to numeric and other data types. Let's look at examples of using count in SQL. The select statement retrieves data, while count aggregates it. By grouping data, we can analyze it more effectively, as shown in the example queries. The MAN and max functions are essential for finding extreme values in datasets. Here, we see examples of using these functions to retrieve birth dates from a database, demonstrating their practical application. SQL also allows for the calculation of aggregates like averages and sums. The AVG function computes the mean, while sum totals values. These functions return NULL if no data is present, focusing on numeric values. Here, we explore examples of using AVG and SUM in SQL. By grouping data, we can calculate these aggregates efficiently, providing insights into data trends and patterns over time. Data grouping in SQL is achieved using the GROUBY clause. This allows for aggregating data into single rows, enabling calculations and analysis on grouped data, enhancing data management capabilities. The having clause in SQL filters results based on groupings. Unlike where, which filters rows, having applies to grouped data. This distinction is crucial for effective data analysis and retrieval. Combining GROUBY and having allows for complex data retrieval. This approach enables filtering groups based on conditions, ensuring only relevant data is processed and analyzed. Understanding the order of SQL clause execution is vital, starting with select and from, followed by where, GROUBY, having, and OR ensures accurate data manipulation and retrieval. Subqueries in SQL are powerful tools for nested data retrieval. They allow for executing queries within queries, providing flexibility and depth in data analysis. Subqueries must always be select statements. Subquery clauses like in and not in enable filtering based on subquery results. These clauses allow for selecting rows that match or do not match subquery values, enhancing data filtering capabilities. The any and all clauses in subqueries allow for comparison across subquery results. Any checks if any row matches, while all requires all rows to match, providing nuanced data selection options. Correlated subqueries are interdependent with the main query. They reference variables from the main query, allowing for dynamic data retrieval based on changing conditions, enhancing query flexibility.
Now let's move on to the hands-on phase to see how these queries work in practice. Together, we'll dive into our movie rental database to turn these concepts into concrete queries. We'll start with simple extractions to get comfortable with aggregation functions. Then we'll gradually ramp up to complex subqueries. The goal here is to see how to answer specific business questions using CTRL. Let's start with the fundamentals. To get a sense of the scale of our film catalog, we use count some ways. Here we are retrieving the total number of films. Now, a small nuance. By counting the email column in the customer table, SQL will only count rows where an email is actually provided, excluding any null values. On the technical side, to analyze our film durations, we use min and max. It's instantaneous, and it immediately gives us the boundaries of our sample, the shortest and longest films in the catalog. Moving on to the numbers. With AVG, we calculate the average transaction amount, which is crucial for defining our average basket size. And with sum, we get the total revenue generated by payments. These two functions are the engine behind any financial report in SQL. Now let's step it up a notch. We don't just want a total, we want a breakdown. Here, I'm grouping films by their duration. By adding an order by NB_films DC, I can instantly see which duration is the most frequent in our stock. We do the same for our personnel. By grouping payments by staff_ID, we can compare the performance or workload of each employee. Pay close attention to this step. When you want to filter data that has already been grouped, you cannot use where, you must use having. For example, here, I only want to see duration categories that contain more than 10 films. Similarly, we can isolate our power users, those customers who have made more than 20 payments. It's an excellent way to target your best customers. Finally, let's look at subqueries. This is where SQL becomes truly powerful. Instead of manually looking for the average and then filtering, we ask SQL to do it all at once. In this query, the parentheses first calculate the average duration, and then the main block displays all films that are above that result. It's completely dynamic. And to go even further, we can even nest complex calculations. Here we are looking for customers whose total spending is higher than the average of all customers. This is high-level data analysis performed in just a few lines of code. There you go. We've covered the essentials of SQL analysis, from simple aggregation to dynamic filters. Mastering these functions means being able to transform any database into a goldmine of actionable insights. Thanks for watching this tutorial.
Thank you for joining our SQL tutorial. We hope you found it informative. Please like and subscribe for more content on database engineering and coding. Stay tuned for future tutorials.